Looking at the night sky, can you figure out if the object is a star or a planet? Yes, you have been learning it from your childhood. The objects which twinkle are stars, and the objects that do not twinkle are planets. The question in today's discussion is, why do stars twinkle? Basically, the reason behind the twinkling of stars is atmospheric refraction. Let's learn how it happens. We live on planet Earth. The atmosphere of Earth consists of layers of air. The particles of air are closely spaced at the surface of the Earth than these at higher layers. That means the density of air is highest at the surface while it goes on decreasing towards the top layer. Now let's talk about a star. A star have its own light. Since they are at far distance from the Earth, therefore looks point-sized and so are treated as point source of light. The light coming from star, that is a starlight, when enters in the Earth's atmosphere, layer by layer, it experiences increasing density and so bend towards the normal at the boundaries between the layers. When it comes to us, we observe the star to be slightly higher than its actual position. Now air is fluid. It has property to flow. So, there are continuous and random variations in every layer of the atmosphere. These changes result in the random change in refractive indices of the layers. So, if refractive indices of these layers are not steady, how will the apparent position of star appear steady? The apparent position changes slightly but randomly. Similarly, because of random changes in refractive indices, the brightness of light coming from star also appears to be changing. The resulting effect of changing apparent position and changing brightness causes star to appear twinkling. Why do planets do not twinkle? The reason is simple. Planets are much closer to Earth. They reflect light falling on them towards us. Since planets are much closer to Earth, they could not be considered as a point sources. Large number of rays coming from such objects undergo refraction in random manner. But while reaching at observer, they nullify each other's effect. That means neither the position of planet change nor there is change in brightness of light coming from them. The intensity of incoming light does not change. It remains constant and so planets don't twinkle.
This is very interesting. You get to see the sunrise before the sun actually rises. You know what happens? Earth's atmosphere has different layers. And also, the optical densities of these layers decreases as you move away from the Earth's surface. That is with increasing height. So, what happens is, just before sunrise, before the sun reaches the horizon, the sunlight enters obliquely into the atmosphere. It gets refracted through the atmospheric layers. Now, this refraction causes the light rays to bend. So, the sunlight actually reaches the Earth's surface in a curved path. Now, what happens from the point of view of an observer? Following the path of the light rays entering the eyes, the observer actually sees the sun slightly above its actual position. And as a result of that, he sees the sun about 2 minutes before the sun actually rises.